Interesting topics today. We have Rachel Noble, who's going to be talking about the viral wastewater testing. And then we have an update from Johns Hopkins teams as well as Palantir on the Enclave knowledge objects. And this is our standard metrics that you guys see. So 88 sites that have signed the DTAs, the 57 sites that have released the data in N3C Enclave, and we have 213 sites that have DUAs executed. So I'm going to turn it over to our external speaker, Rachel Noble, to talk about the viral wastewater testing. Rachel, I'm going to stop sharing and you can share the screen.
Great, thank you very much. All right, is that working for everyone?
Yep, we can see it.
Yes.
Thanks.
Great, fantastic. Well, thank you everyone for your time on this Monday. It turns out to be a very warm Monday for much of the nation. So thank you for joining us. Today, I'm going to talk to you just a little bit about SARS-CoV-2 and perspectives using some of the molecular methods that we're using for wastewater-based surveillance for SARS-CoV-2. The first thing that I'd like to start with is that some of my initial review slides might be just that. They might be review, but it's important for us to kind of gather together our thoughts on molecular methods for wastewater-based surveillance because of the nature of the technology being valuable for aggregate measurements of community prevalence as opposed to individual measurements of a person or a patient status. And so it's just a reminder, some of the slides very early on are basic, but they're a reminder of some of the advantages that wastewater-based surveillance can pose now into the future, but they're also reminders of some of the limitations of wastewater-based surveillance, which I'll talk a little bit more about later on in this presentation. My laboratory has been working really hard on wastewater-based surveillance since we got into this in early March of 2020. As a matter of fact, it was my lab manager who noticed in mid-February that a lot of PPE and a great deal of laboratory reagents should be purchased because she had the wherewithal to kind of see what was coming as far as supply chain issues. And here we are more than a year away from that, but they've been tirelessly working on this topic. And some of them graduate students who have been, whose graduate degrees are on completely separate topics. So I'd like to acknowledge them and our partners at DHHS, CDC, and the North Carolina Policy Collaboratory and NIH from the very beginning. So when we talk a little bit about individual testing and wastewater surveillance, just like I said, this is a very basic slide. But we talk about an MP sample coming from an individual. We've also heard, and maybe you all have participated in pooling of samples to save resources. Wastewater surveillance is essentially a larger aggregate measurement that's similar to a pooling approach, but it has attributes that allow you to look at municipalities, towns, and even sub-sewer sheds, pump stations, lift stations, and in the case of the media, kind of gaining notice on it earlier in the spring was dormitory testing. That's simply another form of pooled testing. It's not at the municipality or town-based level, but it is at a small, very small community level, maybe 300 to 700 individuals in most dormitories. So in any case, this kind of wastewater surveillance has its advantages and disadvantages, like I suggested. I'm basing my talk today on the assumption that many of you know a lot about quantitative PCR and droplet digital PCR. In particular, we use testing capabilities as developed by Bio-Rad and their platforms. We've been working with Bio-Rad for over 2 decades now, using some of their platforms. If there are technical questions at the end of the talk that are more specifically related to the qPCR and the droplet digital PCR, on the side of laboratory reagent setup, on the side of sensitivity beyond what I described today, I'd be happy to have those questions either by email or in the Q&A. So when we talk about wastewater influence surveillance, we are talking about just that. We're not, there was a time early on in the wastewater surveillance based for COVID-19 that there were a large number of people who actually thought that we were trying to surveil or study the effluent discharge coming out of wastewater treatment plants. The opposite is true. We're actually taking the wastewater treatment plant influent as it comes directly from a municipality and from a town. So without getting into the technical details for anywhere that most of you are sitting today, about 50 to 60% of you, maybe more, depending on the demographics of this group, are likely, if you use the toilet, to be flushing the toilet. The material will transport out of the building or home that you're in through a lateral to a main stem line, and that will go through a series of lift stations or pump stations in your small town, or in your larger town. That pump station network will be even larger, and that material will be transported through a series of either gravity or pumped lines through to a wastewater treatment plant, whereby basically the wastewater treatment influent is representing everything that people use in their daily lives: shower water, laundry water, dishwater, and a range of different household activities, plus basically the signal that's coming from the viral RNA of infected individuals, which contains the SARS-CoV-2 viral RNA. To our advantage, many of the viral pathogens that people can become infected with, the stool actually contains high concentrations of that viral RNA. So it might be a little astounding, but in the case of an infected individual, and these numbers have actually been even further updated recently in the literature, we can find on the order of log 7, log 8, and log 9 copies in a gram of feces. That's, log 7 being 10 million copies per gram of feces. That's an incredible amount of viral pathogens. So we have the benefit of using this as a wastewater, as a tracking technology, even though, as you know, the wastewater that comes into a treatment plant is going to go through extensive dilution from a range of different sources as it travels and as it comes out of the home. Individuals begin to shed virus earlier than typically the onset of symptoms. So one of the advantages of wastewater-based surveillance has been that we can actually detect the virus in a system where an outbreak is being initiated before actually that signal is found concentrated in the respiratory samples. Because of this, it actually was that wastewater-based epidemiology was already an active area of research. This has gained a lot of notoriety in the last couple of months to about a year, because of the opportunity not only to use this for COVID-19, but to extend a wastewater-based approach to other pathogens that may be of concern into the future. One thing that I'd like to make sure that everyone in the audience recognizes is that still to this day, there has not been any demonstrated danger associated with the viral RNA, either in the laboratory of people conducting wastewater-based surveillance or in the wastewater treatment plants for the personnel working there. So what we find, or what we believe to be true, is even through infectivity studies, is the material that's being transported through the system is viral RNA, but it's no longer part of an intact virus particle that can make one sick. So we simply have not seen, for example, outbreaks that have been taking place in wastewater treatment plants as a result of aerosolization that many have postulated as going on in, say, nursing homes or congregate care facilities. So from a practical side, we can use the trends in this virus concentration to understand something about the ups and downs associated with outbreaks, and particularly related to mitigation measures like lockdowns, like vaccines, like treatments. We're particularly interested now in the emergence of variants in poorly vaccinated areas, for example. We can use wastewater-based technology in a research format to estimate community prevalence by making assumptions based upon the load of material that's in the wastewater on any given day, and an understanding of what I described previously of this this fecal shedding of the virus in an infected individual. The issue though there is there's a large amount of variability. So we know that we are able to detect infected individuals in the very low numbers and some of our smaller systems, getting down into the 3, 4, and 5 infected individuals based upon data that we have for municipalities and towns. But this estimation of community prevalence must still be understood to be a very it's a variable matter, and it has a lot to do with how diluted the wastewater is. The case that I always present to people is think about the low flow units. Many of you may be on the West Coast. You may be in a system like in a Los Angeles or a California system that relies on entirely low flow technology for your toilets, your dishwashers, and for and even limiting water use in your household. The signal in a low flow water usage and in a semi-arid area will be much more concentrated than it is, say, in a North Carolina area where we have plenty of precipitation, we have plenty of groundwater mixing with sewage pipes, and we also have plenty of water usage based upon tourists and just non-conservative kinds of approaches. One of the things that we can also do is we can use these hotspots in the understanding of what's going on in the wastewater to understand vaccine distribution and understand risks associated with school openings and school related dynamics. So let's move on a little bit from what we assembled in 2020 was a collaborative partnership across academic units in North Carolina, pairing with the North Carolina DHHS to receive money from the North Carolina legislature to basically stand up a wastewater monitoring program. What we did in 2020 was we followed 20 different locations over the course of roughly 6 months. Some of them were monitored since March of 2020, and some of them came online in September 2020. You can see that most of these locations were actually centered around, where our academic institutions are. On the left-hand side of this map, there's a kind of triangular looking shape that represents the city of Charlotte. In the center of the North Carolina map is going to be the Raleigh, Durham, Chapel Hill area. On the right, enclosed with the black lines, is Greenville, North Carolina, and all the way to the coast. On the northern side, there are Beaufort and Newport, North Carolina, and moving down the coast as you move southward, you see systems that represent Wilmington, North Carolina. So this was a large collaborative project. I'm not going to read off the capabilities of all of the people that participated in this project, only to say that the impetus and the momentum that was gained on this particular project quickly turned into participation in the CDC National Wastewater Surveillance System as we transitioned from 2020 to 2021. So what that basically means is, and now this is old because now there are far more participants in the news program, as CDC calls it. And what this is a national reporting of wastewater-based surveillance data for COVID-19 that goes through a set of protocols from each of these states' departments of Health and Human Services, back out to CDC. CDC metabolizes the data into a usable dashboard format, and it's shared back with each respective state, in which case those states share it back in a public dashboard kind of a setting with their constituents. So what we've been doing here is from January until June of 2021, we were managing 10 locations throughout the state of North Carolina because we wanted to stand up basically this CDC participation. And then from there, we've recently gone through an expansion, which I will show you a little bit of information from. So for those of you who are interested in the nuts and bolts on wastewater concentration, and for those of you who may have followed how we do wastewater-based analysis for a range of different viral pathogens, the process is the same. We've been doing work for a few decades now on viral pathogens such as hepatitis A, norovirus, enterovirus, rotavirus, adenovirus, and also have extended into some other work on bacterial pathogens. And in general, when working with wastewater, it's a filtration, particularly when considering the viral pathogens. There's a modification of the pH to capture the majority of virus particles based upon charge. That filter basically goes through a magnetic bead-based nucleic acid extraction. In the case of COVID-19 causative agents like SARS-CoV-2, that goes through reverse transcription and quantification by digital PCR or quantitative PCR. So looking really quickly, what I've done here is I've brought you to the forefront of one of our most recent issues related to our CDC news program here in North Carolina. We have, so you can see represented still here are the 10 locations. This is not the expanded format of the 20 locations that we are now working. We are literally going through this expansion in the past week. I apologize for the formatting here, but I had to borrow a computer here today to finish out this talk, and it hasn't been friendly with me as far as screen sharing. So I just wanted to give you a feel what's shown in the North Carolina map. There are a few kind of Rorschach kind of splotches of gray. Those are actually now mapped sewer sheds that match each of those wastewater treatment plants. So where before we were making estimates of the numbers of people that might be contributing to that wastewater treatment plant, now we have involved advanced GIS-based analysis of the sewer shed infrastructure to understand exactly how many homes and businesses are linked onto each of these different wastewater treatment plants that we're studying. This allows us to understand something about the usage of the system, the industry effort within the system, if you will. The industry land use is what I mean. And what you can see, as shown in the yellow here very simply, is that many of our locations in North Carolina are in what CDC refers to as a plateau. This means that the concentration as coming from February and March has come down due to vaccination, but it's in a plateau and it hasn't gone back and increased. As opposed to the town of Beaufort, which is actually where I live along the coast. It's the red dot all the way out along the coast in North Carolina. You might know that spot in North Carolina according to hurricanes that hit that very spot, hopefully not this year, but in the past. And what we found actually in the town of Beaufort since about Memorial Day is a really stark increase in the number of SARS-CoV-2 viruses in our wastewater system. This is a wastewater system that serves only 4,000 people. And you will all be interested to note that we have one of the most famous and the largest fishing tournaments, bill fishing tournaments in this stretch of North Carolina in the last couple of weeks. And we can't rule out that this increase in the amount of SARS-CoV-2 in the wastewater we can't rule out that it's not due to tourism. We have not, however, seen that there has been a concomitant increase in the number of cases in the town of Beaufort. So it seems like the locals have gone by somewhat unscathed, even though we have a low rate of vaccination, but it still poses some concern for us. So just to give you a feel for how the data is being reported, I apologize at the top, actually, this data is publicly available now. If you care to go to the wastewater monitoring dashboard for the North Carolina DHHS, if you simply Google the words wastewater monitoring and NC DHHS, you will find the wastewater monitoring dashboard. And I can also drop that into the chat after this talk. You can see the increase in the concentrations in the town of Beaufort starting about the beginning of June. And you can see the utility of a technique like this in even a very small rural system that had I not lived there, we probably would not have been working on this system in the first place. The concentrations of the virus have gone even so high as what we had seen in the system back in mid-February, which is quite surprising. Now, wastewater does often peak before the numbers of cases will show themselves because of the fact that we're able to detect the viral RNA early. So it will be of interest to us to keep an eye on this and to see if we see an increase in local cases. This could be, however, viral RNA in the system that is related to people traveling into town. If they were to be suffering any symptoms, they would be tested and their case, if positive, would be reported in their home jurisdiction, not in the location that they were tested. So someone's home address for their insurance, or if not insured, their permanent address is what will be used for reporting. So when we talk a little bit about gaps and areas of investigation, our laboratory is really interested in this understanding of drivers, particularly of rural disease transmission. I've tried to show you this with this very small rural town in Beaufort, but what we're really interested in doing is now expanding out to decentralized systems, to septic systems, and to package treatment plants using more advanced technology that's highly sensitive and really including other pathogen threats. I'm going to spend a little bit of time telling you about droplet digital PCR. I'm going to fly through this section of the talk because I want to make sure that we have time for some question and answers, only to suggest to you that it's a really been a dream to work with droplet digital PCR for the SARS-CoV-2 analysis because it's been highly sensitive. So this is actually a study that's in review and should be accepted for publication, I'm hoping maybe in the next few days. If someone is interested in actually seeing the study, or the preprint, you can feel free to let me know. I'd be happy to send it to you. We didn't get many in the way of critical review comments, so we're expecting it to be produced quickly. Basically, what you can see in our in the digital PCR and in the quantitative PCR is we simply get more data out of the digital PCR than we do with the quantitative PCR, and we get more non-detects with the quantitative PCR, and that the digital PCR is more sensitive. Once again, I'm going to fly through this, but I'm happy to describe some of these plots to you all a little bit further. So what you can actually see when pitting digital PCR and quantitative PCR against each other is that for digital PCR, you simply see that there are a number of data points that are running along from left to right on your screen, and that early on in the, so these are just samples according to week in the pandemic, and early on the qPCR had a lot of non-detects until the qPCR machine was able to start to pick up some of this data as the concentrations went higher and higher. So I'm going to tell you a little bit about variants of concern because this is something that we've been able to do with our wastewater-based surveillance. We've been able to study the variants in using the same format in our wastewater analysis. As you all know, the mutations may help virus spread and in and of themselves become selected in the population based upon infectivity and likelihood of transmission from host to host. When we think about variants, we have to rely on clinical samples to get sequence data so that Bio-Rad can work with our laboratory and others to design new digital PCR and qPCR assays for the new variants. So this is a completely iterative process where the sequence analysis comes out and then new tests are being developed, and we're testing those out on the order of days after Bio-Rad is able to produce these. The other thing that's going on is that as mutations occur, some of the tests that have recently received FDA's EUA authorization are no longer working because they were based upon technology, or based upon a gene region basically that's been modified since then. So there's a range of mutations that are currently tested. Once again, this can get confusing very quickly, but if you use a stepwise process for the quantity that you derive in the digital PCR for a particular variant, you can sleuth exactly what's in your wastewater sample. So to give you an example, if a sample is positive for both N501Y, and it's also positive for E484K, then you would go ahead and test for the Brazilian variant that are listed in the list below K14. And you could also test and to confirm that you have the Brazilian variant on hand. So it's kind of a sequence of analyses that you're using in any particular case to confirm the numbers of variants that you have in your system. So we have 12 weeks of data that we've collected, and we're trying to sleuth out the dynamics of what's been going on in North Carolina and what we can, whoa, excuse me. Not sure what happened there. What you can basically see is that similar to what was seen in clinical cases, we saw over early stages of February and March in North Carolina, where the UK mutant emerged It spiked up to a concentration that you can see with the light blue bars, and then it came down in its relevant concentrations again. This is just at one wastewater treatment plant, but and in one of our major metropolitan cities, so describing hundreds of thousands of people. Similarly, you have the 6970 mutant that's actually confirming the presence of that UK variant. And then you have the 417 that seems like it hasn't gained a hold almost in any case in North Carolina. Now we're continuing to do this type of work over time with the Delta and the Delta Plus variants. And I'd be happy to describe some of that work to you as we go through this wastewater treatment plant surveillance. Excuse me for this, computer is very sensitive. So basically what we're seeing in the wastewater is we're seeing over time an expansion of the UK variant. There are other laboratories that have confirmed this using clinical testing. And so it's an excellent process for us to see the combination of the wastewater and the clinical data in agreement with each other. So when we talk about wastewater-based surveillance, we can look at these beyond the N1 and the N2 targets. We can test these wastewater samples, and as new variants emerge, we can track these variants in wastewater, which has been very interesting and unique, particularly comparing and contrasting, once again, those rural and those metropolitan cities because of the dynamics that you have in these locations with international travel, with tourism, and with other transmission dynamics. So this will be very interesting moving forward. There is a new test that's being marketed by Biorad. I'll tell you so far it hasn't worked fantastically, but they're still optimizing it where you can actually test two variants and one of the N nucleocapsid targets at the same time, thereby saving money. This is just an example of what might be coming in the future as there are more machines for digital PCR that are able to do more colors at one time, meaning more multiplexing. But I certainly wouldn't rest my hat on the design so far for this particular set of multiplexes. We still have some bugs to work out with Biorad on this particular system. So when thinking about the future, we're thinking about wastewater surveillance for North Carolina and across the nation. We're really embedded in the use of a full suite of controls to make sure that everything we do is fully quantitative. I didn't show you any of that, but I'm happy to talk to you about process recovery and extraction efficiency and every step of our process. We're interested in the new Biorad designs, like I said, for Delta and Delta Plus. And there will be triplex and even quadruplex designs that offer potential advantages for the future. And with that, I don't know if I have a minute for questions or so forth, but I'm thankful that you all got to spend a little bit of time today, and happy to hear if you have any questions or ideas.
Rachel, thank you so much. This was really interesting work. So there is a question by Joy Algier. Which RNA segment or corresponding protein are you amplifying in your PCR detection? And there's another question there is, are you able to detect SARS-CoV-2 variants? Question 3 is, are you able to estimate number of infected people from the RNA quantity you are detecting? So I can repeat this.
I'll take all three of those. The first one's really quick. So far, because we are a CDC partner, and because our project so far across North Carolina is funded by CDC, we are focused on CDC-based N nucleocapsid gene designs, and those would be specific for N1, N2. In some cases, some groups have included N3 in North Carolina for resources and to allow us to spend more resources on variants. We've chosen to focus on the nucleocapsid 1 and nucleocapsid 2 CDC designs. There are multiple qPCR and digital PCR designs, primers and probes for those genes, but the CDC has a design, and those are the ones that we're using. On the side of the variants, I think probably you've seen now, we've been trying to track the variants as we go. At first, we were most interested in the UK, the Brazilian, and the South African variant. Certainly now we're very interested in rates of vaccination, vaccine breakthrough, and the Delta and Delta Plus variants. So we have plentiful archived samples that we have, archived extracts, excuse me, that we will return back to and use for our variant analysis. And we're actually working with some partners on conducting full sequencing of the wastewater samples that we've been using for surveillance, so that we can have the data for any tracking purposes that might be useful to come back to in the future. And Usman, remind me what the last question was.
Are you able to estimate number of infected people from the RNA quantity you're detecting?
We are. It becomes a little bit complicated. So I use a really quick example. In a system where, wastewater system where there has been no measurable precipitation in the recent days, and where you don't expect huge portions of the population to be described by influx and kind of efflux according to tourism. Certainly we have some level of comfort with looking at the clinical cases and understanding what's emerging in the wastewater and trying to piece those two together by using estimated values over that 24-hour period. What you can do is you come up with a load. So that's a 24-hour load in the wastewater. And essentially what you're doing is you're taking the load of an infected individual and you're dividing that total wastewater load by the amount that would come out of an infected individual, which is very much an estimate because it depends on the age of the individual. And from there, you can create an estimated number of individuals in the system. That becomes much more difficult if you have a system where any flooding or precipitation has occurred. That water will get into the system, causing dilution of your SARS-CoV-2 signal that has nothing to do with the infected individuals that contributed to it. And so that becomes a little bit more interesting. It becomes more of a kind of it's actually, believe it or not, it's an infrastructure mathematical problem. And so we're working through that with some colleagues to try to understand that a little bit better.
Got it. Thank you so much. I don't see any other questions, but actually, final question, Joy just posted. Have you thought about getting vaccination signal by looking the delta between spike protein / corresponding RNA?
Yes, I actually thought of that about, I have some colleagues who work at a biotechnology company called BioGX in Birmingham, Alabama. And we went through the process of trying to determine how we could use any vaccine component as a tracer. So it turns out, and I'm not a vaccine designer, but it turns out that in the older attenuated virus vaccines, like for polio virus, it was quite easy to design a test that would allow you to track. As a matter of fact, that's what I did for a lot of my graduate work, to allow you to track those viruses into the wastewater system. But it turns out that for this particular vaccine, the process of immune response does not result in any real trackable component that comes out in the fecal contamination. And so I would love if any of your viewers, audience, have ideas on some measure that would allow us to partition a wastewater contribution to understand vaccination. I spent about a month trying to really dive into it, and I just came up with everything. We were looking at how to track IgGs and IgM, all kinds of things. It just turns out that a stool, fecal material, is not the best way to track a lot of these immune response targets. But it's a very interesting question. It's an excellent point.
Great, thank you so much. I think, yeah, that was as there are no further questions. So we can certainly take additional questions via email. Rachel, thank you so much for your time.
Thank you all. I really appreciate it. Sorry for the clunky computer system, but I think it all worked out at least somewhat.
No problem. Thanks again.
Take care.
I'm going to turn over to the next topic. We have another interesting topic. Davera and Harold Lehman and Saad, they're going to be talking about the Enclave knowledge optics.
Thank you. Let me find my, good afternoon, everybody. Whoops. Where's my share? Wrong share button. Here it is. Thank you. Good afternoon, everybody. I'm Davera Gabriel, and I'm with the Johns Hopkins Biostatistics and Data Science section of the School of Medicine and the N3C Data Ingestion and Harmonization workstream, along with my co-presenter, Dr. Harold Lehman. Our third presenter today is Saad Jazuli, who is an engineer with Palantir, one of our technology partners. And we will provide a brief presentation about the Enclave knowledge objects, which are key differentiators that provide value to researchers studying COVID-19 and the translational research community at large. Our presentation today will review how N3C performs as a component of the National Learning Health System. Saad will provide an overview of the N3C Knowledge Store, and we're going to wrap up with an update about the provisionally validated concept set process with a community call to action. First, we'd like to take a step back from the details that we've been working on in the context of broader national goals. As a quick review, a learning health system is a set of practices enacted within the health data ecosystem that produces a virtuous cycle where clinical care feeds discovery, and these discoveries in turn improve population health. N3C, the data enclaves supported by it, and the knowledge objects covered today play important roles in our national learning health landscape. N3C brings data gathered by distributed health networks onto a secure, centralized enclave supporting research. And the knowledge object processes represent the unique opportunity that the N3C centralized data architecture bring to clinical and translational communities. Among the guiding principles N3C is founded on are transparency, inclusivity, and reciprocity. The N3C knowledge objects directly support realization of these principles. Generating and preserving knowledge objects in the enclave supports research reproducibility, as these objects are searchable and available to N3C partners and others, which in turn promotes collaboration. The knowledge objects created in the enclave promote inclusivity among its analytic user community, and contributions retain full attribution through detailed knowledge objects, provenance recording, and versioning. As such, the work of data analysts are preserved for reuse, and their contributions confer to scientific discovery and scientific publications. At this point, I'll turn the presentation over to my colleague, Dr. Harold Lehman.
Thank you very much. In this graphic, you see a conceptualization of really the knowledge work that goes on to go from data, raw data on the left, to an analysis on the right-hand side. The result of the analysis is knowledge, but obviously a lot of knowledge goes in to how to create that knowledge itself. The Legos show you the different types of things we need to construct in order to come up with a variable, because any variable on the right-hand side can be represented by any one of the stacks on the left. So we start with the basic concept ID, which is the raw data that comes in and then gets harmonized and normalized by the data ingestion and harmonization group, and ends up as a cohort definition: who has COVID, or who's pregnant, who has immunodeficiency. And then finally, we sometimes have external data sets that we need to bring in as well to provide variables. It would be great if the data we just heard about were available and locally, but I think that's just going to be North Carolina. The knowledge store is where we share the code, the data to accomplish this knowledge work. So I'll turn to Saad to describe the knowledge store as our key application.
Sure, thanks, Harold. So just a brief presentation of the knowledge store before I turn onto a demo in the Enclave. So the knowledge store is an application within the N3C Enclave. You can actually find this from the homepage. And it's the application where users, researchers can share code logic without necessarily sharing data. They can share reports and documentations. They can share derived data sets, cohort definitions, models, and any other types of knowledge with the other members of N3C community. So you can share what we call knowledge objects in the knowledge store, And you can also reuse or learn from this code logic or any other knowledge objects shared by Enclave users. And so the idea here is that the knowledge store allows you to share logic without data sharing, because users within the Enclave don't necessarily have the same level of access. So that technology allows for that level of sharing. And the objective of it is to promote collaboration and accelerate research, standardized logic when possible, while also being transparent about knowledge provenance and about attribution. Next slide, please. And so there are generally currently 3 types of knowledge objects within the knowledge store. We have code templates, which are basically pieces of code logic in different languages, such as Python, R, or SQL, and/or derived data sets. Users can also share reports, documentations, and we also have external data sets that are not necessarily electronic health records, such as social deprivation index or census data. There are another classification of the knowledge objects, and this is a dynamic list because it depends on the content. Could be, we have concept set templates, we have cohort templates, Odyssey templates and tools, phenotype templates, derived variables, and visualization templates. And currently the knowledge store supports 59 live knowledge objects. Some of the most used knowledge objects are used in up to 21 research projects, and some of them are used up to 143 times. So I'm going to jump and share my screen to do a quick demo. And the idea here behind this demo is to show 4 or 5 examples of knowledge objects while keeping it on a high level. So these knowledge objects are were authored or maintained by various people within the N3C community. So this presentation is based on our understanding and of the documentation they shared. But obviously the best source to ask questions about these knowledge objects would be the authors themselves. So what you see here is the Enclave homepage. And within the homepage, you have a link to the knowledge store application. And so when you click on it, this is what the knowledge store looks like. It's a list where each one of these items is actually what we call a knowledge object. And so when we click on a list, you have more details about the content of that knowledge object. What is it that is shared? Is it a shared logic? We have other information about provenance, documentation, usage metrics, which I'll get into when showing the specific examples I wanted to show. But first, I just wanted to highlight for discoverability purposes, you have some filters here that help you navigate through the existing knowledge objects and find the knowledge object you need. So you have categories, the categories I mentioned, such as concept set templates or visualization templates. But you can also search by the author of the knowledge object, or you can search by the originating research project. So in my case here, let's just take a look at the code templates. And there is a second view here. So this is the high level view, but if you click on more knowledge object metrics, you get more usage metrics. And these are here meant to help you figure out which knowledge objects are relevant or more, or I should say widely used. So it takes a couple of seconds to load, but basically you have more details about each one of these knowledge objects, including the title, the author, when it was created, and a brief description. And what's interesting here is you have the count, the usage count. So for example, you can sort by and look at the most widely used knowledge objects. So this one has been used by 21 separate research projects. You can look at the simple use count. And so first example I wanted to show is some utility templates related to concept sets. So if I just filter to concept set templates, One example I wanted to show here is this knowledge object, which is called compare two concept set IDs, two concept sets by ID, sorry. So when you open it, you have the title and a brief description of what it does. This one is a straightforward template that just makes the comparison between two concept sets to figure out the overlap and the differences. And so if you scroll down here, we have some information about the provenance. So you can see that this knowledge object has been used in these 5 different research projects, and this is the originating research project. You have more information about the usage metrics in this tab, the use count by project, etc. And the thing that is actually being shared is what's in this field, the shared logic. So in this case, it's what we call a code workbook template, which is a piece of code that anyone can reuse within their code workbook, even if they don't have access to the same data that the authors of this template have. So here you can see the parameters that this template takes in, and you can look at the underlying code. In this case, it's an R code. And if you want to use it, you can just click here and then use it in your own research project within your own code workbook. So that's on this one. The second example, which is still a utility template, but is very widely used, is this one called filter OMOP domain table to concept set. And the idea behind this template is that if you have a concept set data set that has a number of concepts, you want to find the relevant electronic health records from the corresponding OMOP domain table. And this template allows you to do that. So this one has been used so far by 6 different research projects. And you can look into the code and what it does by clicking on the shared logic. So I won't take too much time in here, but just wanted to give you the idea behind these templates. I wanted to show also 2 or 3 more involved templates. The first one, let me switch back to the main view, and I'll keep the code templates. This is also an interesting template that has been built by the Logic Liaison, the Logic Liaison team within N3C. This one is basically a code that builds a facts table by patients. So the template puts together various patient level facts, including COVID-19 facts, patient BMI, death data, IMV and ECMO procedures, inpatient visits, and other common comorbidities. And if you look here, so some of the templates have good documentation, and this is being done by the authors of the templates. So this documentation tells you how to use this template, but it also gives you some tips with regards to working with N3C data. For example, the stratification of the analysis by data partner ID, matching on data partner ID when creating a matched cohort analysis, or also like if you have the identified data access, it explains the implications of data shifting and other data limitations. So again, when you click on the knowledge object, you have the overview where you have the title and a small description. The thing that is being shared is, in this case, a code template, but in some cases, the authors also share some code workbooks that you can look into to see how the logic has been constructed. And in other cases, some derived data sets are also shared within the knowledge objects. Second example I wanted to show in these type of more involved knowledge objects, maybe if I search by originating research projects, and I want to look at the templates that has been produced by the cohort characterization project. Some of them here, maybe I should use the search bar for, if I type in critical, I was looking for this template, which is called select critical visits. So this is a knowledge object where in which the goal is to generate a table with 1 critical visit per patient by COVID status and severity. And so there is a methodology to select the most appropriate visits, and it's explained here in this description. And you can see here, in this case, the author have shared a small video to show how to import this template into your code workbook. And you also have, so this one is a quite popular knowledge object. It's being used by 15 research projects, and you have much more examples and documentation here, and an example code workbook. And so the last one, and I'll go very quickly to give time to Davera and to finish the presentation, is called the is a template to find the COVID positive patients. So if I type in positive, this is a cohort template that has a logic, an example workbooks, and resulting data sets that surface all the lists of all the COVID positive patients. And so same here, similarly here, you can look at the documentation to understand how the criteria, how we're defining these lists of COVID positive patients and which concept sets we're using. So that's all for my part. I will pass it to Davera to finish the presentation.
Thank you. So we're gonna now have a concept set update.
So, so you've heard concept sets a lot. They're basically synonyms of concept IDs that mean the same thing, but depends on the analysis that you're going to do. Let's go on to the next slide, please. We have basically 2,000 concept sets that are active in about 250 projects. About 14% of them have a review, which is where either the vocabulary has been reviewed to see that as many concepts should be in the concept set as there is, or a clinical review, where generally somebody says, well, that concept ID does not belong in this concept set because we're talking about antigens, not antibodies, or so forth. What's interesting, as the concept set gets more and more attention, you'll see that there are more and more reviews. So those concept sets that have not been mapped to any project just have 7% reviews, whereas those that have been mapped to many projects, similar to what you saw with the knowledge store objects, they have 84% of those have reviews. So a reviewed concept set basically generally is associated with a project. It has both a clinical and informatics review. It gets, and Davera will show you this in a minute, it gets posted to the provisionally validated area, making it easy to reuse. And the reviews do help you provide attribution of effort for those people who don't have their fingers on the keyboard, but especially the clinicians are doing quite a lot of work in judgment, and this is where we get their input placed in. And finally, if you're going to publish a paper using concept sets, you should have the concept set available publicly, and the review process and its provisionally reviewed process will make it easy to do that. Go ahead, Davera.
Thanks, Harold. So I'm going to give you a quick run through about what this looks like in the Enclave. When you first get into the Enclave, the home screen, you'll see that there's a great big icon. You click on that to get to the concept set browser. And then at the top, there's a button that shows you that if you click on this button, you'll get the provisionally validated concept sets. And this is a way to take a look at those concept sets that have had the more use and more reviews. This is what that looks like. After you click on that button, you'll get a list of the validated concept sets. And then what I did next was put in a keyword of dexamethasone to drill to the particular concept set that I am interested in. One of the things when you pick a particular concept set, you can see there's along the tabs along the top, you can take a look at the member concepts. And a really important feature of taking a look at concept sets is to take a look at this term usage tab, which allows you to visualize how much that concept set is finding signal in the Enclave data. you'll see that there's a dark square there in the middle that I put highlight on, and it shows that for that particularly, it's a heat map. For that particular code, we have and that particular site, we have over 35,000 instances of that particular code. We talked about there's a call to the community you'll hear a lot about this in our domain team meetings, and you'll hear about this from your data liaison. We're really going to encourage a lot of participation with regards to clinical reviews, both for the papers, but also just to help us then reuse some of the concept sets that are in the enclave. To do a review, you're in the particular concept set version, and then you click on create a concept set review. Then you get a pop-up menu, which is pretty simple. You type in, whether it's a clinical or a final review. Most of the time you'll be doing clinical reviews. And this last screen I have to shows that the system knows that I was in there. I'm providing a comment that said that Tel Bennett did the clinical review for this particular concept set. And if you happen to be working with a researcher who doesn't have Enclave access, but is providing you a clinical review of the concepts and a concept set, we also provide free text availability to indicate who those individuals are, so we can track that for all the provenance information. That brings us to the end of our little demo and our presentation on the knowledge objects. Are there any questions?
I don't see any posted so far, so we'll just open the floor for any questions and see if we get any. We're almost at the top of the hour as well. I got one question from Zia Jing. How can a concept be validated? What is the process?
Are you talking about a concept set or a concept? Concept set validation would be validated, at least in the enclave. Concept set, thank you. The way, using the steps that were outlined there, you will need to take a look at the members of a concept set, and your clinician would provide feedback if the members in that set, those concepts, match the intention for that. So to give a very brief example, we were interested in steroids in COVID cases, but then when we would do a broad-based search for steroids, sometimes we would get topical steroids. We would refine that to indicate just systemic steroids. And so when you have whatever the intention is, whether that be refined or originally expressed, the clinician provides the feedback that those members in that concept set match the intention for that concept set.
Great, thank you so much. I don't see any other questions. Thank you, Davera, Harold, and Saad. We'll chat next week. Thanks, everyone.
Bye-bye.